Okay, let me make sure my microphone's on. Okay. So they gave you this one to do the limit of an because it's a little bit easier to tell what's going on, or ak, I guess it's called. And they gave you this one to do the sum. I think this part is easier for the sum of ak. So doing the limit to figure out the first part, the limit, you could have just done the limit because it's in the denominator. What's the degree of top versus bottom? 0. So it's big bottom, so 0. If you're like, you also could have done the fraction out a little bit and been like, a1 is going to be 1 over square root of 2 plus 1. a2 is going to be 1 over square root of 3 plus the square root of 2. What's happening in the denominators? They're getting bigger, so the entire fraction is getting smaller, but it's never going to be smaller or negative, so it's going to approach 0. So we're already between A and C. Okay, then we look at the sum. This part will help make the sum be easier just because I feel like dealing with adding up fractions is not so bueno. So the sum is, we want to find a partial sum. So we're going to do A1. This version will be easier, I think, for you to tell. This one. A2, square root of 3 minus square root of 2. A3, square root of 4 minus square root of 3. Square root of 5 minus square root of 4. Okay, so S1 would be equal to A1, right? And it's just square root of 2 minus 1. S2, S2 is taking S1 plus A2. So you have square root of 2 minus 1 plus square root of 3 minus the square root of 2. What's happening with the square roots? They're canceling, and you're left with square root of 3 minus 1. Interesting. Let's do S3. S3 is S2 plus A3. S2 was the square root of 3 minus 1. A3 was 2 minus the square root of 3. I don't know if you could tell, but it is getting bigger. Let's do one more just for funsies. S3 plus A4. S3 was 1 plus A4 was square root of 5 minus 2. It's getting larger and larger each time. Technically, you could have made up a pattern. The pattern is square root of n plus 1 minus 1. And done the limit as n goes to infinity of Sn. But maybe you didn't notice that. That's okay. You could still tell that these are getting bigger as n is going to, or k, whatever, is going to infinity. These sums are also going to infinity. They're going very slowly, but they are increasing. You see how they're getting bigger? Like square root of 3 minus 1. Square root of 3 is like 1 point, I don't know, something, 2 or something. Minus 1 is going to be 0.2. Then you have 1. Then you have something bigger than the square root of 4. So you have 2 minus 1. So 2 point something minus 1. So you're going to have 1 point something. So these are going to infinity, which is diverging. So whether you came up with the equation yourself, this is like, ooh la la, ooh la la, you so smart. Or whether you saw that it was getting bigger this way, either way, hopefully you could tell that it was diverging. So it should have been C, not A. Yes, Noah.
I'm dealing with that, like the A limit as k goes to infinity of AK equals 0 or does not equal 0, like that part.
Okay, so that part, it was harder to tell, I think, with these numbers, but if you maybe like, even just with these numbers, you can sort of tell. This is like 1.2 minus 1, so it's like 0.2. And then this square root of 3 minus square root of 2 It's like an even bigger numbers that are subtracting each other, so their difference is going to be smaller. 2 minus the square root of 3 is going to be, it's getting smaller.
So isn't a of k never equals 0?
It's not going to equal 0, but it's getting really, it's smaller and smaller and smaller. As think about like a 100. Oh, let's do 101. So you have 100 and 2. Oh, shoot. Hang on. Let's do 100. 100. 101 minus 10. Square root of 101 is like 10.01. 0.00001 minus 10 is 0.00001, right? It's like never gonna be 0, but it's approaching 0.
Oh, the limit. So
Yeah.
the limit equals 0. But
Right.
it's still divergent.
The sum is diverging. The series itself is the sequence.
Okay, so
The numbers are getting smaller, but as I add those smaller numbers in together,
so the limit
they're getting
is
bigger.
0, but the summation is divergent.
correct.
Okay, I think that kind of makes sense.
Okay. Yes.
Is there a rule where, like, I know we didn't have to know for this, but the square roots, if you have like a square root minus a square root, like you flip it, that's what it
It's multiplying by the conjugate on top and bottom. Now, we will learn more rules. This is like the beginning. These are the building blocks to getting series rules. We're going to be learning, actually, I think it's like 7 or 8 series test rules, which theoretically make things easier than you having to say, oh, A1 is this, A2 is this, A3 is this, so now S3 is the sum of those. Instead of having to add them up a bunch, we're going to have series tests so that we can just like skip doing the adding part and skip doing the partial sum part and just like do the test, hopefully faster. We'll see. All right, so on 2, we have AK is -1 to the K. So we're still doing partial sums here. So S1 would be A1, which is -1 to the 1. S2 would be -1 to the 1 plus -1 to the 2. S2 is 0, right? S3 is S2 plus A3, so you're going to have 0 minus 1. So what is the pattern? What do you think S4 is going to be? 0. What do you think S5 is going to be? So we're alternating between 0 and -1, 0 and -1. Is it converging to one finite number? No, since it's not converging to one number, then we would say it's diverging. It has to be going to one thing. Okay, doing the partial sum. This one was also diverging, but that's not what it was asking for. It was asking you to identify the pattern of the partial sums. So if S1, we're finding the sum of 1, right? Because A1, AN is 1. S1 would be A1. S2 would be A1 plus A2, which would be 1 plus 1, which is 2. What do we think S3 is? 3. What do you think S4 is? 4. Look, the ends are matching each other. They're matching. So it's not n plus 1. It's just n. You see?
Wait, but how do you know what A of 2 was?
All of the A's were 1.
Oh.
So A2 was 1, A3 was 1, A100 is 1. All of them were 1. So if I was adding up the first 100 terms, I'd have 100 ones adding together, which is 100. Okay. Today we are going to start our first true series test, the geometric series. Yippee.
Could not diagram.
We're going to learn like 8 series tests. You're testing the series to see if it like converges or diverges. Not, yeah, sure. It's not like a grade test. It's like a series test. Oh, that's the fun kind of test. Yeah, definitely. Okay. Let me try to go slow. Geometric series. There are, we're going to see, I'm going to show you my little chart. I'll give it to you soon, but there are a bunch of series tests. These are all the series tests. Today is our first little test. Yippee. So geometric series test is, I don't know if it's, calling it a special case is the right word, but it's like it has to be a specific format. So for it to be a geometric series, it has to be number raised to exponent, like a variable exponent. That makes a geometric series. It has to be constant to the power of the input. And it can't have any of those input variables. I say input variables instead of n's because sometimes it's like k or sometimes it's j or whatever. But whatever your input variable is, and I know n is the input variable because it's like the subscript of n equals 0. You can't also have that same variable anywhere else. So what I mean by that, if I have the sum of -1 to the n over 2n plus 1, this is not geometric. Even though n is in the exponent here, there's a 2n plus 1 where the n is not the exponent. So this is not geometric. So like, yeah, n was in the exponent, but it can't be any other thing other than the exponent. The second it's not, if it's appearing and it's not the exponent, it's not geometric. So it's not like a special case, it's a specific case. So like specifically when n is only in the exponent. So let's look at example 1. Yeah.
What is the name?
That's just like the first term that it started at. So let's look at example 1 before we talk more about geometric series. I want you quietly in your head and on your paper to try to tell if 1A, B, and C are geometric. So say geometric or not geometric. 1A, B, or C. Okay, so on 1A, is this geometric?
Yes.
Yes. Okay, B, is this geometric?
No.
No. N is not the exponent. How about C? No, N is not the exponent. So now let's talk more about geometric series now that you can hopefully correctly identify them. Geometric series have a common ratio of R. R is the thing that's multiplying. It's a number, a constant, that's multiplying between every single term. So R, if R is greater than or equal to 1, the second it's 1, then you're just having A times forever, like A times 1. If it's greater than or equal to 1, we would say the series diverges. So we are thinking about R. Remember, geometrics are like the same thing as exponential. Think about exponential growth. So as n is going to infinity, the terms would get bigger and bigger and bigger and bigger and bigger. So it would be diverging. If R was 0, you'd be left with 0. So then it's also just like not really a series anymore, it's just 0. Because adding up 0 plus 0 plus 0 is 0. So Okay, I guess it's converging, but it's not like a sum. It's just 0. So if r is between negative 0 and 1, absolute valued, then it would be converging. So it's approaching some kind of horizontal asymptote. I don't want you to think that it's converging to the horizontal asymptote, because that's not necessarily true. It's just converging. The numbers that you're adding on each time are getting smaller and smaller and smaller. So things to know about geometric series. These are things I've noticed over the years. They don't need to start at n equals 0. They can start anywhere. What I mean by start at is you in this equation you have n equals 1, but really, or 0. It could be 1, it could be 2, it could be violet, it could be blue. Oh wait, no, just numbers and whole numbers. So it could start at 0, but it could start somewhere bigger, and it doesn't mean that it's not a geometric series just because it started at somewhere else. Also, the exponent just has to involve n. If n is adding, subtracting, multiplying by something, it is still geometric. So the exponent so for example, the exponent could be like 2n minus 1.
But it can't?
Oh, sorry. Can. Thanks, Graham. This is still geometric. Because there's still only n in the exponent and nowhere else. It's just like using properties of exponents to like make it look less gross that you would need to do. But so it's still geometric if you have something adding, subtracting, multiplying, or dividing n. Other things that I want you to keep in mind is that you have a sum formula. We're going to learn a special case telescoping today, but really on the AP exam, the only time the AP exam is ever going to ask you to add something up is if it's geometric. Geometric series are the only types that have a sum formula, and this is the sum formula. Everything else we're just saying converging or diverging. So this one is the one we can actually approximate now. This is the sum formula for geometric. What does it stipulate has to be happening? When can I use a sum formula, Zeppelin? Yes. So we're going to talk more about this once we do a couple of these, but even if a series diverges, couldn't you still plug some numbers into this formula and get a number? Like you could plug in 10 over 1 minus 5 and get a number. That doesn't mean that that number means anything if the series is diverging, right? So like a lot of times people are like, but I used the sum formula, Ms. Russell, and I got 10. And I'm like, cool, that didn't mean anything. It was diverging. Like you cannot use the sum formula if it's something that's diverging. It doesn't sum, it diverges. So we only can do this when it's converging. And this number, think of this number as the first term. So an is the first term. I think Graham asked that. What's a? If you look over here, what was a? A was the first term in the series. And then we're multiplying it by r consecutively after that. Okay, to go through, you might have to rearrange things. R is only when it's to the positive n power. I want you to kind of go through A through maybe D and identify if it's what R is and if it's converging or diverging.
So equals no, use greater.
Huh? Yes.
Well, wait. Are we sure diverges? This is the negative. Well, wouldn't to the negative n be 1 over e to the n, and wouldn't that then converge to 0? I believe so. Ms. Russell? For d, since it's e to the negative n, wouldn't that be 1 over e to the n and then converge to 0?
I don't know if it converges to 0, but it does converge.
But it converges.
Yes.
Yeah, or equals 1 over
And same for D.
Right. Because we like plug
yes. So r equals negative 0.75, and then we do. Oh, we probably have to use this. Yeah, you're right. So it's the first term is 1. E to the, so n is 0, so it's just 1. So it's 1 over 1 minus. Yeah, I believe so. I think that we can do that, right?
Yeah.
Yes.
I think would diverge.
Sounds good. Next one, negative 0.75. It's gonna converge, right? To the first term is 3 times negative 0.75.
All right, what about A? What's R equal? 1.1. Is that less than or greater than 1? So what do we say? Diverges. Stop there. Don't plug into the sum formula because does the sum? No, it's going to infinity. It's just going to get bigger, 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 bigger forever. So don't plug in. Once you write a D, D means don't keep going. Okay. How about B? B was tricky. A little bit of properties of exponents.
Not for us.
What was R equal to? 1 over E. What is E approximately? 2.7. So is this less than or greater than 1? Less than 1. But we are converging. If it converges, I did want you to find the sum. I don't think I said that yet, but let's just finish converging or diverging. All right, on C, we really need to find the absolute value of R. So the absolute value of R would have been 0.75. Less than or greater than 1? Less than. So therefore, converges. Okay, and on D, R was 1/2, which is less than 1, converges. Now for all the ones that converge, I want you to find the sum. Okay, so I'm going to show you how to deal with the sum for B. So on B, we're doing the sum is A over 1 minus R. Some of our friends are not so good at the algebra, so we're going to try to go nice and slow and show you all of the algebra steps. What would A equal? What's the first term? 1. You have 1 over e to the 0 because n is 0. So I'm starting at 0. I'm plugging that in to get A, which is 1. So if S equals 1 over 1 minus 1 over e. Ooh, that was fun to say. This is okay to stop on a free response question here. However, this is not usually a free response question. This is usually a multiple choice level question. So on multiple choice, do you think that they're going to have a fraction over 1 minus a fraction? No. Say no, because no. So we need to be able to simplify fractions. So what's one thing that you should probably do?
Common denominator.
Common denominators. You could multiply by e over e to everything too. That would get rid of. I think I heard someone saying that. So we have 1 is the numerator. And then e minus 1 all over e is the denominator. I wrote this 1 like this to help me remember that my numerator was 1 and all of the denominator was e minus 1 over e. So when I have a fraction divided by a fraction, what do?
Keep, change, flip.
Keep, change, flip. So I'm keeping the first fraction, changing the sign to multiplication, and then flipping the bottom. What you're actually doing when you keep, change, flip is you are multiplying the numerator and denominator by the same number, right? Like it's like a fancy form of 1. This is for our friends who work at like Mathnasium to know what you're actually doing. When you teach the Algebra 1 kids about keep, change, flip. So it's a fancy 1, right? Same over same.
I've said that
And they
so
canceled. And then this is what it sums to. Ooh, wow.
Do you know why we're multiplying by square root of 2 over square root of 2?
You know how much gray hair I've gotten by multiplying by 1 and having to explain that over and over and over again in my life? It's been a long 15 years of saying fancy ones. Okay, on C, it converges. Find the sum. And I want to point something out to you so you don't get tricked. Where is it starting at?
1.
It is not starting at 0. It's starting at 1. Be careful.
I can't do that in my head. Oh, I can.
Change it to a fraction.
Yeah, that's what I did. Negative 3/4 times 3 is negative 9/4. Okay. Negative 9/4 over
Change it to a fraction.
1.
3 times 0.75. Ew.
Plus 1.75, right?
It's the first term. So I had to plug in wherever it's starting.
Over
Tricky.
7. Because A isn't actually the first term. A isn't like the first term that's there. A is the first term once you plug in.
Like wherever you're starting from. We started at 1 this time. That's not fair. I know that one started at 0. This one's starting at 1.
That's why.
Remember I told you it could start anywhere of a positive integer?
So negative 9/7.
8 is angry.
Next one.
You can do it. What? No, you just plug in 2. So it would have been 3 times 9 sixteenths. So 27 sixteenths would have been A. Yeah, good question.
Very good.
Okay.
I like this.
Okay, so in the denominator for the sum, we're not doing the absolute value. You want it to actually be like we are subtracting, we're multiplying by negative 3/4 each time. So it will be alternating between positive and negative. You want to have like the essence of the question. So the absolute value is just there when we're trying to figure out if it's converging or not. But when we're actually plugging in R, we are using negative 3/4. So you should have 1 minus negative 3/4. And we're going to get common denominators. Change that to a plus sign. Some of us at this step can tell that it's going to be negative 9/7. Some of us need to keep, change, flip. It is all good. Do whatever works for you. Just please, for the love of God, get it right. It converges, and this one does converge to negative 9/7. Okay? You could have also said it was negative 36 over 28 and then reduce that. But why go bigger to go smaller? Then
Go big or go home.
no. Go small or go home. Reduce it. Okay, on this one is easy. I think this will take you 2 seconds. Ready, set, go. Is that one? Oh, I thought you said one. Oh. And so I was like,
Yeah.
Nate, what'd you get for the sum of this one?
6.
Wow, that was fast. Yippee.
Should ask David.
I should have. I have a little bit of trauma from last class, though. I haven't recovered yet. He's wounded me.
You should start checking Davis's notes.
I really should. All right. These, I think, are, well, E's not tricky. But F maybe will trick you. And G, we're going to put some stars by. I asked G on a quiz last year or something like this, so yeah, it's okay. You're not just babies. You are smart toddlers. What does R equal for E?
That's not fun.
No.
It's 1. No, 3.
3 halves. I don't think you were looking at the right place. So it's greater than 1, which is diverges. So I don't write what I'm about to write in purple. I just want to call something to your attention. If you, you lost your mind for a second, reason, decide to plug in, you'd have 1 over 1 minus 3 halves, right? And so that'd be 1 over negative 1 half, I think. Yeah? No? Yeah, okay. And so you have negative 2. You get a number. Does this number mean anything? No, it diverged. This series, the second term is going to be, you're going to have 3 halves plus 9/4 plus 27/8 plus 81/16. It's getting bigger and bigger and bigger, and you're adding on numbers that are growing. It's going to infinity. This is growing. So this means nothing, even though you can plug into a formula and get a number. That number is meaningless. That is the most common issue where I'm like, you have to check geometric series, whether they diverge or converge. You cannot, yes, it is possible to use the formula if they diverge, but it is not appropriate to use the formula. It doesn't make sense. Okay, so don't do that. Don't be that kid. Okay. On F, I am hoping that by asking this question and questions similar to this, I will break you of the idea that E and pi are variables. They are numbers.
No.
Yes, they are numbers. So what is E about equal to?
6.
Okay, what is,
7.
oh Lord, 3.14-ish, right? So we got ish. So what is this, bigger or less than 1? Less than 1, so it would converge. What's the first term? 1. So we have 1 over 1 minus E over pi. Could multiply numerator and denominator by pi. That would make things easier. Do you want me to show you what I'm talking about?
What?
Instead of keep, change, flip, you could say the least common divisor would be pi. Right? And then like distribute. And you're going to have pi over pi times 1 minus E. Which is what you'll get when you keep, change, flip. Ooh. Ah. You're getting better at math. That's crazy. I know, it's crazy. Because that would have been the common denominator, you know what I'm saying? Multiply, reciprocal.
I'm picking up what you're putting down.
I'm glad. Okay. Get the common denominators, add them together, keep, change, flip.
Yeah.
Okay, on this one. Okay, let's also do a little fireside chat here. Let's have a little moment. Me and you, just me and you, okay? So 2 minus 3 over 5 versus 5 over 2 minus 3. I have seen you guys do some terrible algebra recently, so I just want to make sure we clear the air, you know? Can I make 2 minus 3 over 5 be 2 over 5 minus 3 over 5?
Yes.
Why?
Because it's the same denominator.
Right, there's a common denominator. Yes. Okay. Can I make this be 5 over 2 minus 5 over 3?
No.
¿Por qué? Not common denominators. Okay, just checking. Some of you have decided to reinvent the rules of algebra to make your integrals be better for you, and that's I'm so sorry to tell you that's not how that works. So please don't do that. I don't know what you just said, but I'm scared. Okay, so on this one, can I break apart this fraction at the common denominator? Yes. Let's do that.
That got you really excited,
Wow, that's an algebra hater in the crowd, I think.
Me?
I don't know. Whoever said shut up to Graham being excited about algebra being so fun is an algebra hater.
Graham, keep talking.
Okay, so if you have a summation plus or minus a summation, and either part of them diverges, the entire sum diverges. Because if one part's infinity, infinity minus 2 is still infinity, right? So if either part of the sum you get diverging, then slow down and just put diverging, right? It's over. Now, I think most of you can tell that neither of these are diverging because r is 2/5 and then 3/5, so neither part is going to diverge. But I'm going to do some helpful algebra for you, for our friends who did algebra in LPS or something. I don't know your life. 2 to the n minus 1 would be 2 to the n times 2 to the negative 1, right? Because when we have the exponents adding, we're multiplying their bases. Zeppelin? It absolutely could. I don't have a strong feeling either way on that one. I kind of generally like to get it to b to the n power if I can. But in that situation, I think you could have written it as 2/5 to the n minus 1 and been a-okay. Okay. Interesting. What's going to happen to the 2 to the negative 1? Goes into the denominator. What's going to happen to the 5 to the negative 1? It goes to the top, so we're going to have a 5 over 2 times 2 over 5 to the n. Their summation. What's going to happen to the 3 to the 1? It's going to, no. It's going to stay because it's to the positive 1. Tricked you. And then 5 to the negative 1. It's going to go to the top. So you're going to 15. Shh. Don't say it so meanly. Let's find out. Okay, so we have 15 times 3 over 5 to the... Yeah.
It's okay.
Why does it not impact the,
It does. It's not to the n. It's not to the n.
No, the other one. It's 3 to the n times 3.
Right, so it's just these two are multiplying.
You can just split the fraction like that.
Mm-hmm.
You only distribute if it's like two brackets and it's like it's addition or like subtraction happening in the brackets. But if all three terms are being multiplied by each other, like you don't have to distribute multiplication.
Wait, Miss Russell.
Either way, if everything is multiplying, the exponents can, as long as they go with wherever they need to go, you don't need to bring it to both of them.
Miss Russell.
Yes.
So if you have like 1/2 to the power of n minus 1, you have to do that thing, right? To get the a.
Not necessarily. You can just plug in 0 and then it would be 2.
Oh, so a is always just if you plug 0 into n.
Yeah, this is just to help it make it look a little bit nicer. So you're looking at it now and you're like, oh, this feels like more approachable. Like I'm not as scared. There's not as many plus signs in the exponent. All right, so this one, r is equal to 2/5. Smaller or bigger than 1? Smaller. So it converges. R over here is 3/5. Less than 1. Also converges. So because both of these are converging, I'm going to find the sum.
We can do the first sum minus the second sum.
Yes.
Isn't the 5/2 and the 2/5 multiplied to 1, and then the 15 and the 3/5 multiplied to 3? Or like 6.
What?
Like it's 5/2 times 2/5.
No, because it's the 2/5 is to an exponent.
Yeah, you have to do the exponent before you this.
PEMDAS.
Why is it doing that? This is more powerful than multiplication. Right, like E comes before M and D. Okay, so we got, what is our first term here on the green one? 5/2. What is the first term on the blue one? 15. Okay, just checking. So we got S is equal to 5/2 over 1 minus 2/5 minus 15 over 1 minus 3/5. Okay.
We're gonna leave.
No, we're not. We're gonna, you can multiply everything by 5. Just saying. Huh? But I think that I'll do it the old school way just for you. Roop, roop. 25 over 6 minus 75 over 2. 75 times 3 is what? 250? No. 225?
What's 75 times 3? 225.
Nice one.
Thank you. For time purposes, I'm going to skip example 3. It's just kind of like a fun fact. So we're not going to learn anything fun or facty today. Don't worry about it, sweetheart.
What if that's on our quiz?
It won't be because I'm skipping it.
She's not going to put it on the
I'm
quiz.
so kind
On
of
the
confused why
21st.
they made it a 15 and like 5 and half through the end.
So you have 3, because the 3 to the n, the 3 had to get to the n first. Like you have to do P in PEMDAS. So the e, that 3 is being raised to the n. And then you have 5 times 3. They're not to the same power.
Wait, so you just like don't have this?
That's how I got 15.
Yeah, I know 15 is 5 times 3, but it just like doesn't
Right, because they're not to, the 15 wasn't to the n power.
Telescoping series. Although telescoping series are not a part of the AP Calculus BC curriculum.
Because it is an important member of the series family.
Guys, you don't want to learn more series? Look, you got a cool little picture of a telescope up there.
It's so cute.
Think about it like this. I can't hear what you're saying. I can't say that.
Let's look at the telescoping series. I personally love the telescoping series, and I plan to put it on your quiz and on your test. I think the telescoping series is also great because it will use prior skills that we've learned this year. Maybe like partial fraction decomposition. But it's so easy. Let's find out how easy it is.
Enjoy these reactions.
I do. It's like it feeds my soul. So we have, if we have B1 minus B2, it has to be number minus number. It's usually fraction minus fraction, but number minus number. B1 minus B2, and then we add. Do you see how the B2s are canceling out? And then the B3s are canceling out? And then the B4, and then it would cancel out until you get to the last term. So the partial sum is going to be the first term minus the last term. How cutesy. Then if we're taking the limit of it, we're going to see if it's converging or diverging, etc. So let's do the first one. So telescoping, it's easy if you plug in a couple of values of n. So let's plug in 1. Where are we starting? 1. Yeah, 1. So we have 1 over 2 to the 1 minus 1 over 2 squared plus, plug in 2, 1 over 2 squared minus 1 over 2 cubed. I'm doing that calculation while I write, just in case you're confused. And then plus n equals 3. So now I have 1 over 2 cubed minus 1 over 2 to the 4th. I almost said to the 16th. Okay, and then let's go down a line. Let's plug in k minus 1 so you can kind of see what's happening. 1 over 2 to the k minus 1 minus 1 over 2 to the k minus 1 plus 1 is 2 to the k. Plus n is equal to k. 1 over 2 to the k minus 1 over 2 to the k plus 1. So now, do you see anything that will cancel out?
Yes.
The fourths, what else? The eighths. Do you think the 16th is going to cancel with like n equals 3 term?
Yeah.
Yes. How about if I had plugged in like n equals k minus 2, what would have canceled? K minus 1, right? And then do you see that the k's, the 2 of the k's are canceling each other out?
Yeah.
Nothing's going to cancel the last term out. So you're really left with this partial sum of 1 over 2, which is the first term, minus 1 over 2 to the k plus 1. We want to find the limit of this partial sum as it goes to infinity. Oops, I guess this is technically a k. First term versus second term, which part is the limit actually affecting? The second term. So we have 1 over 2 minus 1 over 2 to the infinity. What's 2 to the infinity equal to? Infinity. And then we have, then it would be 1 over infinity, which is 0. You were skipping steps. So this converges to 1/2. Yes.
You get just 1/2 for the SK. Like for the SK equals above the limit.
Yeah, because the fourth canceled out with the fourth.
No, like right there. And then limit B, 1 over.
When I do the limit, there's no k in this one to do the limit to,
But why?
because there's no variable in it.
Because n equal 1 and 2 to 1.
Oh, is that what he's asking?
Why does it?
Let's do b. Is it fraction minus fraction? So I need to split up and have fraction minus fraction form. So I split. How do I split rational numbers up? Partial, fraction, decomposition. Okay, let's do heart eyes.
I was actually really disappointed with this one.
It was on the test. Yikes. Well, feel like it was the last question on the test, and it was like at least one multiple choice question on the test. It was number 2 on everyone's FRQ. I might need to reevaluate my grading of his number 2.
No, you did a great job.
I just probably don't know.
Sure. We'll go with that. So remember, when you're doing these, you can do convenient values of n, or you can do a system of equations. I know that Delta Math did like convenient values of n. Oh, that was not what I meant, right?
I prefer the system.
So you could do it this way and be like, okay, a is equal to 1. So if a is equal to 1 and then n equals 0, then you'd have a, oh, wait, that was 0. Negative 1. Then you'd have 1 is equal to negative b, so b is equal to negative 1. That is one way to do it, or you would have said 0 is equal to a plus b, and then 1 is equal to a, and you get 1 is equal to a, so then that means that b is equal to negative 1. Either way, I don't care. Just get it right, for the love of God, okay? So we got sum, let's get my way. Sum of, I usually like to write the positive thing first and the negative thing second. You do you, boo. I think some of you probably already see the pattern or the rule. What do you think the pattern is going to be? Right, the first term minus plugging in like n. So this is equal to 1 minus 1 over n plus 1. But you might be like, oh, what, how did you do that? So some of us might want to expand it out a little bit. Let's expand it out a little bit. We get 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus a bunch of crap, and then 1 over n minus 1 over n plus 1. And all that bunch of crap is going to cancel out and leave you with 1 minus 1 over n plus 1. I do want to caution you on something that is not necessarily always true. It's not always the first minus the last. These two cases have always had these denominators being, the denominators being 1 apart. Give you first minus last. So look over here. The denominators had n being 1 apart. So it was the same pattern. On example 5, we're going to see when it's not doing that. Yay. Even if you screwed up which number was the last number, as long as you have the beginning part of the sum being correct, you see how it's always going to just be like those first numbers. It's going to be 1 minus 1 over infinity, which is 0. Like 1 minus 0. Try to do the partial fraction for 5. Until you get to like some n number or k or whatever.
So it's not saying to use a over n as like to keep this one together. It's just saying to continue.
So like n equals n term.
To what?
I put in n equals n.
What is that bit? Well, I just don't get it.
You're just plugging in numbers until you get to some, you don't know what it is, it's just some stopping point
Yeah,
to
but
get a partial
like
sum.
when you write it as 1 over n or k or whatever, it's like I don't know how to explain what I mean. It does that come from the a over n?
It comes from stopping at that spot.
Okay, so it's not saying like this whole thing has to go again.
Yeah, it essentially does, but yeah.
Hey, but we didn't do that on this one, did we?
We didn't have to do the partial fraction, we already split up. Well, we did it right here. We stopped that for the last time. Okay, and then this one.
Okay.
Other thing I noticed is some of you guys don't really factor very well, and that's a big yikes. Just like watching your test. I have a lot of trauma from that test.
I know more.
You have trauma. I have trauma. You might want to go a little bit deeper into the. Do you have number minus fraction minus fraction?
Yes.
Okay. You might want to try to like, I don't know,
They do, just keep going.
n equals 3 or 4. I promise they cancel if you've done it correctly. All right, so hopefully we'll do it all the way out for our friends who PFD is no good. Mm-hmm.
Once you get the first term, if you know that the whole, like, I guess, last term or second term is gonna end up having a 0 because it's not like the bottom, why do you need to keep going? Can't you just say that first term is the limit?
Like, is it though? Like, is that the partial sum?
Huh?
We're trying to get the partial sum, but in like a multiple choice moment, it doesn't matter. But like in a doing it correctly moment,
No, I do, but like, once you get the answer.
okay, so I'm going to put 1 over n plus 1 just because I want to have the negative number second. It really does not matter though, as long as you have the positive 1 over the correct denominator. Okay. So, pausing so that you can make sure you've written it down. Example 4b versus example 5. 4b, how far apart were the denominators? 1. And we started with the first term and we ended on the last term. Now, how far apart are the denominators? 2. 2. That's going to change things up. That means we're going to have to add up the first 2 things. So there's going to be 2 things remaining. So it's not going to just be the first number. There's going to be another thing that's not going to cancel, which is why Nate was like, we're not canceling. 2 things are not going to cancel. What do you think if it was like n, 1 over n minus 1 over n plus 4? How many things would not cancel? I think 4. 1 over n minus 1 over n plus 4. I think you were thinking n plus 1. But yeah, that would be 4 things not cancel. Oops. And if that's for our friends who are good at patterns. Our friends who are not good at patterns, just plug in. Okay, plugging in n equals 2. I'm going to have 3 minus 1 over 5. Okay. Plugging in n equals 2. This was 1. This is 3. 1 over 4 minus 1 over 6. Isabel? Okay. I think maybe I'm going to plug in, just to be sure I don't screw it up. Minus 2. I think some of you see the pattern either way, and some of you don't. I don't know what to tell you about that one. Okay. K plus 2. Maybe one more. Just take the K. K plus 1. Okay, so when we had them 1 apart, the first thing didn't cancel out and the last thing didn't cancel out. Now, when we have them 2 apart, the first thing didn't cancel. Is there ever going to become a 1 over 3 as n's getting bigger? No, so the 3 is not going to cancel, but the 5, I think the next term, if I did n equals 4, would have been canceling out the 5. Then I tried to expand this out more obnoxiously than I ever would want to, but the k plus 1 is canceling out with each other, and there was previous terms that would have canceled out the k minus 1 and the k. Wait, is it k? If I did k minus 3, I'd have.
What's canceling out the negative 1/5?
This one, 1/4?
No, what cancels out the 1/5?
Oh, the next term is 1/5
Oh.
minus 1 over 7. So your partial sum is 1 over 2 plus 1 over 3 minus 1 over k plus 2 minus 1 over k plus 3. Now maybe you screwed up what the fractions were at the end and you canceled out the wrong things. Lila, when I take the limit as k goes to infinity, do you think it really matters if I had 1 over k plus 2 or 1 over k back there? No. What's going to always happen? It's always going to be 0. So you're always just really care about the first terms and getting those right. So you're always left with 1 over 2 and 1 over whatever numbers. I don't want to say always 1 over 2. Now, if I was like, hey, show me your work, I should see some kind of fraction at the end there that you're like, something didn't cancel out at the end. And that limit makes that be 0.
How do you know at the end, like, how do you know to do n equals k minus 2? Like, where do you...
It's like the last, these are the last two negative ones.
What?
Right. But, like, when you say you're plugging in n equals k minus 2, like, where do you come up with that?
I just like stop at k, and then I'm like, well, they're 2 apart, so I backtrack 2.
So you always are going to plug in n equals k at the end?
Yes.
Okay. And so then, if they were 4 apart, like that one example, you would start with n equals k minus 4,
Yeah.
and then...
Or you could just like, no.
Yeah.
Yep.
Should find the pattern, you always have to just plug in numbers until you see something?
I mean, I personally know that I knew the first 2 were not going to cancel. One, I've done this enough times, but also because they're 2 apart. Like the n plus 1 and the n plus 3 is 2 apart. So the first 2 positive things, if I plugged in, are not going to cancel. And then the last 2 negative things are not going to cancel. Right. Versus on this one, the first term, they were 1 apart, so the first term didn't cancel, and the last term didn't cancel. But basically, it's like really always going to add up to like the numbers at the beginning of the series.
What happens to the
1, 6.
It's always
The
gonna
1, 6 further on would have canceled out with a 1, 6.
How do you know that?
Because the numbers are getting bigger, right? Like I'm adding in n equals 7, and then it's going to cancel out, and then n equals 8, and those are
so
going to...
anything...
Those are always going to cancel out, but they're canceling out 2 steps of like 2 ends after it. Like this 4th didn't cancel out until I plugged in and 2 more bigger. And 1 more bigger didn't cancel out, but 2 more bigger did cancel that one out. And then 2 more after n equals 3, so at n equals 5 is going to cancel out the 1, 6. Like they're always just going to...
What was that?
So at n equals 3, you got a 1, 6 that didn't cancel out. 1, 6. N equals 5 would have canceled out because it was 2
Because the denominator is getting
bigger.
It's like not getting bigger though. It's like if you were to say numbers
It's the denominator is going 2, 4, 3, 5, 4, 6. The left denominator is getting bigger by 1.
yeah.
Left denominator bigger by 1.
Yeah.
Right denominator bigger by 1. So the denominators are all respectively getting bigger.
Oh, so like basically like the 2 smallest denominators are like
Yes. Yes,
and
exactly.
You know you have to keep 2 because there's it's n plus 1
And then,
plus 3.
yes.
Okay. Thank you.
You're welcome. All right, on our paper that I handed out to you, I almost forgot to do this. Ah, yes. So I gave even our iPad girlies a blank one of these. We could put it under our pillow. We could put it on our mirror in the bathroom or somewhere. We're going to need to know everything on this. There's a lot to know. So geometric series. Look at the special format. Do you see the format? How n is the exponent? Okay, how do we know if it converges?
If
R is
between 0 and 1.
Not inclusively, right? Between 0 and 1. Diverges if R is bigger or equal to 1. Special note, this is the only one that sums. So if it says, find the sum of this, it's probably a geometric series. And the sum formula is A over 1 minus R. Yep.
R is 1, how does it diverge?
because it would be like the sum of A then.
Most of the time, A's been like 1 itself or not itself.
Okay, so when A is 1, if A is 1, then you'd have 1 plus 1 plus 1 plus 1 plus 1 plus 1 as we go to infinity. Right, so it's getting bigger forever. The sum of 1 is still growing forever. All right, on our classwork, we are doing the evens to 12.
What?
So 2 through 12 even. And then we're also doing 16 and 18.
So all even.
Yes.
That's a lot of problems.
You'll be okay. I'm telling you, if my second period's finished. Oh, I didn't hand this up to you. If my second period's finished, you guys can finish it in class today.
What if you do R? Or just
R
like
is equal to 0, then it's like 0. The sum of 0 is 0. It's like not a series.
so what is that?
It would be 0. So I guess it's converge, but it's not a series. It's just a constant.
Yeah, but like if R is like, I don't know, 1 half, then like when we plug in that 1 half, so
Yes.
wait, what number is like all the even
Yeah.
The test corrections are extra credit. Oh wait, also, there's no extra of this.
No, you should keep it.
Should I put this one under my phone?
Yes. I want to help you do number 7 to help you do 8. So I'm going to do 7 so you can do 8. I should probably look at 7.
Except for yeah, no, she said all of them. Wait, actually, that's not what she said.
So I'm doing 7 so that you can do 8 because I'm not going to do 8 for you. But on 7, to make this converge, what would make it be convergent? If the absolute value of x over 5 was less than 1, right? And greater than 0, technically. So the absolute value of this being less than 1 is an absolute value inequality. In absolute value inequalities, you have the original way that it looks. And then you have the opposite. When you have the opposite, you multiply both sides by a negative. Both sides of this is what I'm talking about. I don't know why it's not like trailing it for me anymore. So multiplying both sides of this, but by negative 1. Negative 1 multiplying an absolute value, the absolute value deflects the negative. But if I'm multiplying both sides by negative, I flip the sign around. So I'm going to have x over 5 is greater than negative 1. You could also make a compound inequality. That would probably be a good idea. So you have x is greater than negative 5 and x is less than 5. But in order for it to converge, it also means that absolute value of x over 5 cannot be 0. Because if it were 0, it would just be a constant. The sum of 0 is equal to 0. And I guess you could think of that as converging, but that's just not even a sum. That's just a number. So what would not be allowed to have happen? X can't equal 0.
So it's from negative 5 to 0.
Wait, so then do we get choose
Sure.
any number?
Yeah.
We get choose any number?
No, the answer is from negative 5 to 5 without x being 0. That is all the values of x that would make this be convergent.
Can you repeat that? Why it's not 0?
Like, I think it being 0 is not like bad. It's just like makes it not be a series.
Oh, so that's all you have to do.
Okay.
Because if I'm finding the sum of 0, 0 plus 0 is 0 plus 0 is 0, 0 like it's no longer adding anything because you're adding up zeros. So it's just kind of not a series
That
anymore.
makes sense.
Yep.
How do we know that's not equal to 0 just because it's in between?
Right. So like what would make x over 5 be 0? Yeah. Huh?
No, but it could be 4.99999.
Yeah. Mhm.
So that like
And it could be negative numbers, Nate. That's why it's absolute valued. Is because of the negatives.